How can I improve Python correlation performance on large datasets? Imagine trying to find meaningful relationships in a mountain of data. That's what correlation analysis is all about. When datasets grow into millions of rows or thousands of features, calculations can slow to a crawl. But don't worry, there are ways to speed things up and keep your analysis smooth. First, understanding how correlation works in Python helps. Libraries like Pandas NumPy and SciPy make it easy to compute correlations. For example, Pandas core method calculates Pearson or Spearman correlations directly on data frames. But on huge datasets, this can become slow because it computes all pairwise correlations, which takes a lot of time and memory. To improve, consider reducing your data size first. If you have many features but fewer samples, try selecting only the most relevant features or use dimensionality reduction techniques like principal component analysis. This reduces the number of calculations needed. Next, switch to more efficient data structures. Instead of Pandas data frames, use NumPy arrays because they are faster for numerical operations. NumPy's CoreCove function is optimized for speed and can handle large arrays more efficiently. Handling big datasets that don't fit into memory is another challenge. Break your data into smaller chunks or batches. Process each batch separately, then combine the results. This way, you avoid overloading your system and keep calculations manageable. Approximate methods can also help. Instead of calculating every correlation exactly, use techniques like projecting features into lower dimensional spaces or applying spatial indexing. These methods give you good estimates of the strongest correlations without doing all the heavy lifting. Parallel processing is another powerful tool. Use Python libraries like multiprocessing or unknown to run multiple correlation calculations at once across different CPU cores. This can cut down your processing time significantly. For very large or high-dimensional data, specialized tools like PyNet Core are designed for speed. They use chunked strategies, approximation algorithms, and statistical controls to handle millions of features efficiently. For example, replacing Pandas core with NumPy's CoreCove can boost speed. Processing data in smaller pieces helps manage memory and allows for parallel execution. If you're working with complex datasets like in bioinformatics, these tools can save hours of processing time. Combining these strategies, using faster data structures, batching your data, applying approximation methods, and leveraging multiple CPU cores can make a big difference. You'll get your correlation results faster without sacrificing too much accuracy. Remember, always test your approach on a small subset first to ensure it works well before scaling up to your full dataset. With these tips, you can handle large datasets more efficiently and keep your data analysis workflow running smoothly.